Hey everyone, welcome to This Explainer. Today, we're diving into a really fascinating new research paper from May 2026 that actually solves a massive bottleneck in artificial intelligence. We are looking at how researchers are finally teaching AI to click, type, and navigate software exactly the way we humans do. I mean, imagine an AI that doesn't just write code in a little text box, but can actually log into your CRM, pull data, and send emails for you. That's the threshold we're crossing today, and it's super exciting.
All right, really quickly, here is our roadmap. We'll look at the training bottleneck holding things back, why current datasets are basically flawed, and then we'll dive into the genius of the CUA-Gym pipeline and its training environments. We'll wrap up with the groundbreaking model results and what this whole open source drop means for the future.
Okay, Section 1, the CUA training bottleneck. Let's get right into the exact limitations currently freezing the field in its tracks. First up, some quick definitions so we're all on the same page. CUA stands for Computer Use Agents. These are the AI models built to actually navigate software interfaces. And to train them properly, researchers want to use RLVR, reinforcement learning with verifiable rewards, basically giving the AI definitive, hard math feedback on whether it nailed a task. Now, RLVR has been an absolute game changer for math and coding, but for CUAs, it's hit a massive brick wall. Why? Well, unlike a math equation that has a very clear right or wrong answer, a computer interface is messy, it's dynamic, and it's constantly shifting.
So the real bottleneck here is a severe scarcity of scalable training data that actually provides those deterministic rewards. To train these agents, you need consistent instructions, executable environments, and verifiable rewards to know if they succeeded. Let's say you tell an AI to, buy a blue shirt online. How do you mathematically prove it actually did that without a human physically looking at the screen? Did it get to the cart? Did it hit purchase? Those deterministic, verifiable rewards are incredibly rare, which makes training at scale pretty much impossible.
Moving on to Section 2, flaws in current datasets. Because, we really have been trying and honestly failing to solve this data problem up until now. Historically, we've been stuck choosing between two deeply flawed options. On one side, you have hand-curated benchmarks. Humans painstakingly build these so the accuracy and reward fidelity are fantastic. But man, they are incredibly slow to make, meaning they only cover a tiny sliver of apps. On the flip side, you have LLM-as-judge datasets. This scales up beautifully, but you're relying on a language model to guess if another AI succeeded. It's highly unreliable. It's literally like having a distracted student grade the rest of the class. So we're stuck choosing between perfectly accurate data that's way too small or massive data that's totally unreliable.
To break this terrible compromise, the researchers figured out that data generation essentially needs three solid pillars holding it up at the exact same time. 1, consistent task instructions, so the agent knows exactly what to do. 2, executable environments, meaning the software has to actually run and respond to clicks, not just be a static screenshot. And 3, verifiable rewards for that mathematical proof of success. They realized pretty quickly that relying on slow humans or flaky MLM judges wasn't going to cut it. They needed a completely new system to perfectly balance scale and accuracy. Which brings us right to Section 3, the CUA-Gym pipeline. This is their brilliant, fully automated data factory. Okay, so here's the genius part. CUA-Gym is a highly scalable pipeline that co-generates everything, the task instructions, the environment states, and the reward functions all at the exact same time. Instead of humans doing the grueling work of programming every single outcome, they built an entire ecosystem of distinct AI agents that talk to each other. They work together to manufacture perfect training scenarios from scratch. It's basically a fully autonomous data assembly line. Let's peek under the hood at how this automated workflow actually operates. It's a 3-step dance. Step 1. A generator acts as the builder, setting up the initial scenario and the golden state, the target that needs to be reached. Step 2. A discriminator steps in as the strict teacher, analyzing that golden state and writing the actual Python code for the reward function. And finally, Step 3. The orchestrator acts as the manager. It drives the execution through iterative rounds, passing feedback back and forth to make sure the generator and discriminator are perfectly aligned before approving the scenario.
But they didn't stop there. To make sure the data coming out of this factory isn't just vast, but genuinely impeccable, they added a really strict quality control phase. It's a final filter that combines LLM majority voting with actual agent rollouts. Basically, they test drive the scenarios to absolutely guarantee they are solvable. By mathematically verifying these training bundles, or tuples as they call them, they ensure the output is just diamond-tier quality. This goes way beyond what a simple automated loop could ever do. Section 4. Expanding training environments. Because, well, an AI can't really learn to use a computer if it doesn't have any actual software to practice on, right?
To fix the sheer lack of practice environments, the team synthesized a massive new system called the CUA-Gym-Hub. This is a broad suite of high-fidelity mock web apps grounded in real-world software distributions. Put simply, they built a massive offline replica of the internet. We're talking fake e-commerce stores, mock email inboxes, simulated project management tools. It's a safe playground that looks and acts exactly like the real thing, so the AI can train without actually breaking live software. And they didn't just build like a handful of test sites. They synthesized 110 highly detailed, totally distinct mock applications. By grounding the dataset in this wildly diverse ecosystem, they expanded the scale of verifiable training environments by a massive order of magnitude. Suddenly, the AI has this incredibly rich, complex digital world to explore. And when they let their automated factory loose across those 110 environments, the result was staggering. Over 32,000 perfectly verified training scenarios. Seriously, just think about the thousands of human hours it would take to build that manually. In one fell swoop, the whole data scarcity bottleneck holding back computer use agents was completely shattered. Section 5. Groundbreaking model results. So, the big question. How did these models actually perform when trained on all this new, synthesized data? Well, the testing results are absolutely phenomenal. On the really rigorous OSWorld-Verified benchmark, their 3 billion parameter model hit 62.1% accuracy. And their larger 17 billion parameter model, it hit a staggering 72.6%. To put that into perspective, this completely destroys previous open source records for computer use agents, which historically sat way, way lower. They didn't just beat the baseline, they completely rewrote the standard. And what makes this so compelling is that it's not just about hitting a high score on one specific test. The models show incredibly smooth performance scaling when you ramp up data volume and environment diversity. Crucially, they even improved on the held-out WebArena benchmark. That's a completely separate test the AI had never even seen before. This zero-shot transfer learning proves the AI isn't just memorizing clicks or cheating the test. It genuinely understands how to navigate software, and it can bring those skills into completely unfamiliar environments. And finally, Section 6, the open source future. This is, without a doubt, the most exciting part of this whole explainer. The research team stated right in the paper, we will open source the full synthesis pipeline, dataset, CUA-Gym-Hub environments, and models. They aren't hoarding the finished AI or keeping their methods under lock and key. They are literally giving away the blueprints to the automated factory. By handing the keys over to the entire open source community, they're ensuring that future research into software navigation is going to accelerate exponentially. Which leaves us with a really profound question. With the CUA-Gym pipeline out in the open and an automated factory fully capable of generating its own perfect training data, what limits are really left? How quickly are we going to see AI agents go from navigating mock environments in a lab to seamlessly executing complex, multi-step tasks right on your personal computer? Thanks so much for diving into this fascinating explainer with me.